All right, we're here with Jordan to talk about the area of polygons, okay? So first, polygons are just many-sided figures, and there's a few. We're going to talk about trapezoids, regular polygons, and then we'll talk about irregular polygons. Ready to go?
Yeah.
Okay, so first let's talk about trapezoids over here. Okay, so remember a trapezoid is a quadrilateral with only one pair of parallel sides. So let's draw one of those. That trapezoid, that shape, has the top and the bottom are parallel, but the left and right are not parallel, right?
Right.
Okay, that one's a pretty regular, nice looking symmetrical trapezoid. But you can have trapezoids that look like this too, where the left and right are also not parallel, but the top and bottom are, okay? All right, so now let's discover the area formula for a trapezoid. So what I'm going to do is I'm going to draw a trapezoid here, and really there's three measurements that matter. There's the length of that bottom base that we'll call B1. There's the length of the top, which we'll call B2. I know it's not the base because it's not resting on it, but we'll call that B2. And then there's the height, that's H, okay? All right, now let's go ahead and draw a line from one corner to the other, and it won't be dividing this trapezoid exactly in half, but it will be dividing it into two parts. And we're going to talk about the area of each of those two parts. Make sense?
Yeah.
Okay, so first let's talk about the area. Oh, first let's shade it so we can see that there's really two triangles there. And let's talk about that first triangle, the lower left one there. What would the area of that triangle be?
Base times height. Half base.
One half base times height, and the base in this case is?
B1.
B1. So does this look right? The area of the blue triangle equals 1/2 B1H.
Yeah.
Okay, good. Now let's talk about the other triangle. Now the problem is that we have a base for it, which is B2, but we don't really have a height. We have to draw that height in. So we have to go ahead and make our dotted lines. And it's kind of like this triangle is upside down, but if you were to flip it over, you could see that that dotted line that's going up and down, that's the height, right?
Right.
Okay. Now, do we have to do an H1 and an H2 here for the two different heights of the triangles, or do you see something that could help us out here?
No, they're the same.
They're the same, right? Because if we look at this over here, the height right here is going to be the same as the height over here. So when we label this here, we can just label that with H. Okay? Now, so what's the area of that other triangle? Not the blue one, but the one that's on the upper side.
1/2 B2H.
1/2 B2H, right? So that's the area of the green triangle. Okay, so the area of the whole trapezoid is just those two things added together, right? 1/2 B1H plus 1/2 B2H. Does that make sense?
Yeah.
Okay, so we could leave it that way, but sometimes people like to make formulas a little bit more user-friendly. So do you see any parts of the term 1/2 B1H that are the same as 1/2 B2H?
1/2.
1/2 is the same. Anything else that's the same in both terms?
H.
The H. So we could pull the 1/2 and the H out of the of each of those terms, and we could then put B1 plus B2 in parentheses. Does that make sense?
Yeah.
Okay, so that's area equals 1/2 H times the quantity B1 plus B2. That's one form of the area of a trapezoid. We could also just kind of rearrange things so that we can put the H kind of on the other side and then put that B1 plus B2 over the 2, like this. That's just the same exact thing that we just had, but we're just rearranging a little bit. Does that make sense?
Yeah.
And that's another way that you'll see the area of a trapezoid formula written. It's kind of interesting because B1 plus B2 over 2, that's kind of like the average of the upper base and the lower base. So that's one way to think of how you're getting the area of the trapezoid too, is you average the upper and lower bases and then you multiply it by the height. Any way you think about it though, these are the two formulas that you can use. Make sense?
Yeah.
Okay, let's skip over to some regular polygons now. So remember, a regular polygon is a many-sided figure with all sides equal in length. Okay? Probably the one that you're most used to is a square. It's a four-sided regular polygon. All four sides are the same length, right?
Right.
Okay? So let's talk about something that's more than four sides. Let's go ahead and draw this. This is kind of a stop sign shape. Do you know how many sides that is and what it's called?
An octagon?
It's an octagon. How many sides does it have?
8.
8. Very good. Okay. Now, if we were to say, okay, what's the area of that octagon? You might say, gosh, I don't even know where to start. I could divide it up into squares like I would on graph paper or something like that and estimate when there's a partial square. You could do that, but you can also divide up shapes just like we were dividing up this trapezoid over on this side. We can divide this one up. And what I'm going to do is I'm just going to draw in some lines here that divided into 8 different triangles. And do those triangles look the same or different from one another?
They look equal.
They look exactly the same, right? Because the sides of the octagon are all equal to one another because it's a regular octagon. And then we could drop our height for one of those, drop our line there to find the height of one of those triangles. And what would the area of one of those triangles be?
1/2 base times height.
Base times height. And in this case, we put S because that's the side length of an octagon. So we use the word S for side. So it's going to be 1/2 S times H is the area of one triangle, right?
Yeah.
Okay, how about for the whole octagon? How would you set that up?
The area equals 8 times 1/2 SH.
There you go. So the area of the octagon equals 8 times 1/2 SH. And what's 8 times 1/2?
4.
4. So we can say that that is 4 SH. So the thing is, you don't have to memorize the area of an octagon formula or anything like that. But when you're presented with a regular polygon, can you divide it up into triangles now and then calculate based on the triangle area?
Yeah.
Okay, very good. All right, last, most or many shapes in life are not regular polygons, they're irregular polygons. Let's pretend that you had a shape that looks something like this. Maybe it's the wall on the side of a building or something. You need to know how much paint to buy. So you need to know the area, or maybe that's the shape of your yard and you need to know how much grass seed to buy in order to plant there, or something like that. Now it looks like, wow, there's no way we could come up with a formula to calculate the area of this, but do you see any shapes that are kind of hidden within this shape?
Yeah. I see a triangle and a rectangle and a trapezoid.
Good, that's very great. So we can draw in some lines here and we can put a triangle on the top, a rectangle in the middle, and a trapezoid on the bottom, right?
Yeah.
And we can find the area of all those. We can put in some measurements here. So if the bottom base is B1 and the first height is H1, and then that next base is B2, and then the height of the rectangle is H2, and then the height of the triangle is H3. And then you can see we don't have to write in every single thing. For instance, we don't have a base 3 of the triangle. Why don't we need to write that in?
Because it's the same as base 2.
That's right, exactly right. So this gets kind of easy for us. So then a real world situation here, now you can just calculate the whole area. The area of the trapezoid is just our formula that we found earlier. The area of the triangle is just, the rectangle is just B1 times H2. And then, that should say B1 times B2 times H2 for the rectangle, that's right. And then the triangle is just 1/2 of that, B2 times H3. And if you were to calculate the total area, what would you do with those 3 formulas?
Add them.
Just add them up, right? And then you could calculate how much paint you needed to buy or how much grass seed you needed to buy, right?
Yeah.
Okay, great job.